Hello good day viewers. In this tutorial we are going to find a solution to this interesting complex equation. We want to find the value of x that will satisfy this equation, I to the x equal to e to the pi. Alright, let's get started. First of all, you should know that I is the same thing as square root of negative 1. So instead of I, we are going to replace it with square root of negative 1. So we have the square root of negative 1 but raised to the power of x. And the right hand side remain the same, e to the pi. Alright, according to one of the laws of indices, it stated that if you have the square root of a, this is the same thing as a raised to the power of 1 over 2. And hence, our equation becomes negative 1 raised to the power of what? 1 over 2. But remember, we have x attached. And this still equal to e to the pi. Remember, Euler's formula stated that e to the I pi plus 1 is equal to 0. Therefore, e to the I pi must be equal to negative 1. Therefore, instead of this negative 1, we are going to replace it with e to the I pi. Remember, we are solving a complex equation. So our equation becomes e to the I pi for the negative 1 raised to the power of, if you multiply this, you have x over 2, x divided by 2, and the right hand side remain e to the pi. We can multiply both exponents by 2 just to clear this 2, multiply this by 2, multiply this by 2, so that the left hand side of our equation becomes e to the I pi raised to the power of only x, because this 2 will cancel this 2, right? And this is equal to e to the 2 pi. We are moving. Let us multiply these exponents according to one of the laws of indices. This is e to the I pi times x. This is equal to e to the 2 pi. From here, this pi will cancel this pi, right? If you divide both exponents by pi. So the left hand side, and we can equate the exponents since the bases are the same. Therefore, ix is equal to 2. And now let us multiply both sides by I. For a reason, multiply both sides by I. Because I times I is negative 1. So negative 1 times x is negative x to the left. And this is equal to 2i. And lastly, we multiply both sides by negative. Hence, x equals negative 2i. And this is our solution. But we can always check it in the main equation to test whether the solution is true or not. Our main equation is I to the x equal to e to the pi. We want to show that the left hand side is equal to the right hand side by replacing x with negative 2i. Let's do that. So I to the x is now I to the negative 2i. But we know that I is the same thing as square root of negative 1. So we can change this to square root of negative 1. This is square root of negative 1 raised to the power of negative 2i. And this is equal to negative 1 to the power of 1 over 2, right? This is the same thing as square root of negative 1. We also multiply by negative 2i. And we know that negative 1 is the same thing as e to the I pi, right? So we have e to the I pi, then multiplied by 1 over 2, multiplied by negative 2i. From here, this 2 will cancel this 2. What do we have left? We only have e to the I pi multiplied by negative I, because 2 is gone here, negative I. Then if you multiply these two exponents together, we have e to the negative I times pi, multiplying the exponents together. I times I is negative 1. And we already have a negative sign here. So the negative 1 becomes positive 1 after multiplying by negative 1. All we have left is e to the pi, which is exactly as our right hand side. Our right hand side is e to the pi. Hence, the solution to this problem is nothing but negative 2i. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.